Okay, so before we get into the lesson for this section, actually, which is called Special Right Triangles, it's on the second page of your notes. Looks like this. I have this first page on here called Intro to Radicals because I just want to briefly cover a few things that you may or may not have done in Algebra 1. I don't know, but usually we don't get to this stuff. However, it is kind of important, and I'm not going to go spend a whole lot of detail on it, but I just want to be able to cover a little bit of it for you guys so you don't get lost. So radicals, and I didn't give a diagram on here, but radicals, if you remember, they are anything that's under a square root or a cube root or a fourth root. Anything that is a root of some number. Doesn't really matter what number, okay? So when we have radicals, we can actually multiply them by first multiplying the coefficients together. Then we can multiply the radicands, which is what's underneath the square root, under the root symbol. We can multiply those using what we call the product rule, kind of similar to exponents, but this is with radicals. And our product rule for radicals is just the square root of a times the square root of b equals the square root of a times b. So you just multiply whatever's under those radicals together, and then you can simplify from there. We can also divide with radicals, and so what we do is we break apart the radicands, so again, what's underneath the square root bar or the root symbol, using what we call the quotient rule. And that tells us that if we have the square root of a divided by b, that means I have the square root of a divided by the square root of b. I can just break it up into pieces. Okay. So we can then look for perfect squares in those radicals and simplify them. The last thing that's important with dealing with radicals is what we call rationalizing the denominator. So in order for something to be, an expression to be fully simplified, means there has to be no radical left in the denominator. So there cannot be a square root, a cube root, any kind of root of any kind in the denominator of a fraction or of our final answer. So, and this can sometimes occur when we're dividing. So the process of eliminating that radical is what we call rationalizing the denominator. Okay? So in order to rationalize the denominator, you multiply both the numerator and the denominator by the radical in the denominator and then simplify. And I'll kind of show you down here in just a second what we do with that. So I just wanted to kind of do a little bit of practice here just to show you what I mean, how these rules work. So let's look at the first one. If I have the square root of 5 times the square root of 3, I can use my product rule and take the square root of 5 times 3, which is going to equal the square root of 15. And so I was able to just simplify that by combining them together. Now I can't simplify the square root of 15. I don't know what that is. So I can put it in my calculator, but we don't want to do that. We're just going to leave it as a radical like this. But it is simplified now. Notice I didn't have any coefficients in front of these. Number 2 does, so I'll let you kind of think about what you're going to do with those based on what the directions say up top here. So looking at number 3, again, moving forward, I'm obviously dividing here. That's what I was trying to say. I'm obviously dividing here. And up here, our quotient rule says that if I have the square root of something divided by something else, a divided by b, then I can split it into 2 pieces, square root of a divided by the square root of b. It works backwards as well. I can also combine those 2 together. So I can actually make this equal to the square root of 14 divided by 2, which equals the square root of 7. So I was able to simplify that by using that quotient rule, putting those together, and then simplifying it down to the square root of 7. Okay? And again, I don't have coefficients in front of these terms on here, but think about what you think you would do with the coefficients as far as the difference between I guess using the Bradington quotient rule with those involved. I was kind of let you guys think about that. Number 5, this one is one where I have a radical in the denominator. So in order to get rid of that, I have to do that. I have to rationalize the denominator. And so how we do that is we multiply both the numerator and the denominator of the fraction by the radical in the denominator. So I multiply the top and the bottom of my fraction both by the square root of 5. When I do that, if you notice, I'll kind of just write this out off to the side here. Square root of 5 times the square root of 5. If I use my product rule, that's going to give me the square root of 25, right? Well, the square root of 25, we know it's a perfect square, so that's just going to equal 5. So when I multiply this denominator, this radical in the denominator by itself, I'm eliminating that square root sign, essentially. That's what I'm doing. So it's leaving me with 6, maybe, 6 times the square root of 5 divided by 5. It's just canceling out that root sign underneath there for me. Okay? And then I see if I can simplify from there. I can't. I'm finished. Okay? So, let's see here. Let's go ahead and, I wasn't going to look at 6, but I do want to look at 6. All right, so here's another one where we have to rationalize the denominator. So again, I'm going to do the exact same thing. I'm going to multiply both the numerator and the denominator by the square root of 8. That's going to let me get rid of that radical down there, the denominator there. So that's going to leave me with 4 square root of 8 over just 8. Okay? But pay attention to what you're left with here as far as your coefficients. 4 over 8. Now, hopefully, you should be able to see that that can be simplified. 4 over 8 is equal to 1/2. Right? So I can simplify this radical, change this to a 1 and this to a 2, leaving my final answer 1 square root of 8 over 2. Now I'm actually simplified. Yeah, I rationalized, to get from here to here, I rationalized my denominator. However, I wasn't fully simplified because of that 4 and 8. They can be reduced. Okay, so go ahead and do 2 and 4, and then there's 2 more on the back page that I just kind of threw in there that I just want you to think about. And then we're going to go ahead and now actually start the notes for this section. So let's see here if I can move forward. Okay, so now on the special right triangles notes, there are 2 different types of what we call special right triangles, okay? They have special qualities that let us, based on knowing the degree or the angles, we can find the sides easily, okay? So the first one is what we call a 45-45-90 degree triangle, okay? And that is when it's obviously a right triangle, but the other 2 angles are both 45 degrees, okay? So when I have this kind of triangle, I can set my leg equal to x, either leg in this case, because the legs of a 45-45-90 triangle are always congruent, okay? So either of my legs can be x. They're both going to be x. They're equal, okay? And then the cool thing about that is if I know my leg, then my hypotenuse is x equals the square root of 2. So I can use this knowledge for special circumstances in these special triangles. So let's look at number 1. When I have a triangle here, it is a right triangle based on this angle here. It says it's a right triangle, okay? And this angle here is given to me is 45 degrees. That means this angle is also 45 degrees. Okay, so this is a 45, 45, 90 triangle. Notice I only have one side here. I have one of the legs, which is 8. However, because it's a 45, 45, 90 triangle, I know that, this side and this side are congruent. So I already know that x equals 8. X equals 8. Okay. When I know the legs, because this is the leg, these are two other legs, I also know the hypotenuse because of this little handy formula up here. The hypotenuse is x, or one of the legs, times the square root of 2. And so that's how I leave that. 8 square root of 2. And that's it. So x equals 8, y equals 8 square root of 2. Okay? So it's as simple as that. As long as you know one side of a special right triangle, you know the other two. So let's look at number 3. Unfortunately for us, this one here, we weren't given the leg, but we were given the hypotenuse. So think about how we could use this info to find what both of those legs are. I mean, we already know because it's a 45, 45, 90 triangle, we know that x equals y. So we know that these are both going to be the same. Okay. We also know that this hypotenuse here, 19, is equal to, and I'm just going to use x as the example, the leg x times the square root of 2. If we set that hypotenuse equal to this x square root of 2, we can use algebra and solve and find the value of x. So we would just divide both sides by the square root of 2. And that would leave us with x equals 19 over square root of 2. Unfortunately, I don't have a rationalized denominator. I have that square root of 2 in my denominator. So I have to get rid of that. I have to multiply both the top and the bottom by the square root of 2. Okay, that's going to rationalize that denominator and leave me with 2 there. But up top, I'm going to have 19 square root of 2. And that's x, that's it. I can't simplify. I can't take 19 divided by 2. I can't simplify that at all. So that's it. X equals 19 square root of 2 divided by 2. And since x equals y, y is also 19 square root of 2 divided by 2. And that's it. So that is a 45, 45, 90 triangle. Okay. So go ahead and if you want to take a second and do 2, that's fine. If you're not, we can come back to it. But we'll go ahead and move on because this one's a little bit trickier. These are what we call, the next ones that we call, special right triangles are what we call a 30, 60, 90 triangle. Okay. And so that is when we have a right triangle where one of the angles is 30 degrees and the other is 60 degrees. So that means there is a shorter leg and a longer leg. So the shorter leg is always opposite the 30-degree angle. And then the longer leg is always opposite the 60-degree angle. So here's my 30-degree angle. That means this one here opposite is my shorter leg. And then this is my 60, so the one opposite it is the longer one, is the longer leg. So the shorter leg is always equal to x. We'll let that always equal x. So this one right here is x. The longer leg is then the shorter leg x times the square root of 3. So this one here is x square root of 3. Then the hypotenuse is always 2 times the shorter leg, 2x. This doesn't make it too terrible, okay? So we can use this to find each of the missing variables in 4 through 9. Actually, I think there's more on the back. Yeah. But for right now, we're just going to be looking at 30, 60, 90s on 4 through 9. We can use this missing info to find, we can use the info we're given to find the missing variables. Sorry, can't get my words straight. All right. So in this triangle, if this is my 60-degree angle here, that means this is my 30-degree angle. So the side that I'm given, 5, is the one opposite my 30-degree angle. So that means it is the shorter side. So both of the things that I'm trying to get, both the ways I'm going to try and find x and y are going to be based around this shorter side 5. Okay? Because if you notice, the longer leg and the hypotenuse are based on what info we're given from the shorter leg x. So if my shorter leg x is 5, or my shorter leg is 5 in this case, x in this case is going to just be 5 times the square root of 3. I can't simplify that. I can't do anything with it. I can put it in a calculator, and it's going to give me a hot mess of a decimal, and I don't want to do that. So I just leave it 5 square root of 3. And then y is just equal to 2 times that shorter side. The hypotenuse is just equal to 2 times that shorter side 5. So just y equals just 10. And that's it. So all you're doing here is paying attention to which values you're given and plugging them into those equations. So go ahead and skip 5. I want to look at number 6. And number 6, okay, here's our 30-degree angle. I always try and look for, okay, where's the 30-degree angle? What's the side opposite of that? Because that's going to be my base number. Okay, well, my side opposite of that here is x. Okay, I don't have my shorter side. So somehow these two pieces, this longer leg and the hypotenuse, relate back to this value x. Okay, well, I know that 32 is going to be equal to 2 times that shorter side x. So 2 times x in this case. Okay? So now all I do is solve for x. And so then x ends up being 16. So that side was not too bad to find. And then once I find that shorter side, it's all smooth sailing from there. Because if I know now that this side is 16, I know that the longer leg is just 16 times the square root of 3. And that's that. So sometimes I just have to go a little extra step further to find what that shorter side is. Okay, so let's skip 7. Let's look at 8. 8's a little bit trickier. Okay, so this was my 60-degree angle, so this means my 30-degree angle is this one here. So my base side is going to be this y. Okay, well, I don't have that. I do have this one here. This side is my longer leg. Okay, remember my longer leg is equal to the shorter leg times the square root of 3. Okay, so my shorter leg in this case is y. So in order to find what that value is, my longer leg, which is 20, is equal to y times the square root of 3. Because y is representing my shorter leg this time. And my longer leg is equal to my shorter leg times the square root of 3. Okay. So again, now I use my algebra and I find what y is. Okay, so divide by the square root of 3. Y equals 20 over square root of 3. Unfortunately, I have to rationalize my denominator first, so I multiply both the top and the bottom by the square root of 3, leaving me with y equal to 20 root 3 over 3. Now, 20 isn't divisible by 3, so I can't do anything there. It's just, I just leave it. 20 square root of 3 over 3. Okay. So that wasn't so bad. However, now I still have to find this x. Now, remember, x, in this case, which is representing my hypotenuse, is equal to 2 times the shorter leg. So now I know my shorter leg now. It's 20 square root of 3 over 3, which is kind of a hot mess. So what I do there is, I'm going to set it equal, x equals 2 times 20 square root of 3 over 3. Now you can put this in a calculator and it's going to give you out some long nasty decimal thing that we don't want. Or what you can do is just multiply 2 times the 20 in front of the radical there. So 40, square root of 3 over 3. Okay. So now we know, oops, that looks like 20 equals x equals that. There we go. So now we know what this hypotenuse side is. It is 40 square root of 3 over 3. Okay. So if you'd like me to explain a little bit more about how you got from here to here, go ahead and ask. I can explain that to you there. I just want to make this video as short as possible as I can for you guys so you can move on. So some of you may be able to see it right off the bat, others may not. So just ask me if you have questions about that. I want to just briefly look at number 9. Once again, we're not given our shorter leg like we need, but we're given the longer leg. And it's kind of in this nifty form, though it is already written 9 square root of 3. Okay. Since our longer leg is equal to x square root of 3, all that means x is here is that 9. So x just equals 9. Because 9 square root of 3 is equal to my shorter side, x, times the root of 3. Lucky for us, if I sat here and divided both sides by square root of 3, it'd cancel and x would equal 9. Oops, I didn't mean to delete that. There we go. And then you can use that to find y. Okay. So you could go ahead and pause, catch up, do 2 if you haven't, do 5 and 7, and finish up 9. And then when you're ready, we can move on. There are a bunch on the back. Let's see here. I want to just go ahead and at least look at 19 together, so I can get you guys started when I throw a few more shapes in there this time. So now I'm given 2 different triangles here. Look, they're both right triangles though, which is great, because then I know some info. Notice how this one here, let's see if I can draw here. This one here is a 30, 60, 90 triangle because I have that right angle and an angle of 30 degrees. So this is a 30, 60, 90 triangle. If I set aside this other triangle for right now, and I don't want to look at it, I just want to look at my one here. I know my shorter leg already. Here's my 30-degree angle. Opposite of that is this side, this leg length of 9. So that means I already can tell z for sure. Z is equal to 2 times 9. Okay, cool. So z equals 18. I can already deduce that. All right, now I got to look back at this other triangle. Well, here in just a second. It's not asking me for any info on this side of this 30, 60, 90 triangle, but I need to find it anyway because I'm not given enough information on this other triangle to find x and y yet. But because these 2 triangles are connected, This long leg on the 30, 60, 90 is the hypotenuse of the 45, 45, 90. I can find that. Because my short leg is 9 on my 30, 60, 90, that means this leg is 9 times the square root of 3. Okay? So now I can use this to find x and y. Now remember, this is a 45, 45, 90 triangle that I'm looking at here now. This one right here. Okay? And so that means x is equal to y. So I can find them, I can kill two birds with one stone by just finding one of them. So I'm going to focus on x and use that there. So if one of my legs, x, is, or sorry, if my hypotenuse is 9 times the square root of 3, that means it is equal to my legs, x, times the square root of 2. Okay? So because this 9 root of 3 is my hypotenuse here, I need to use that to find my other two legs. And if you need to look back on the front page and remember, like on this one here, when we knew what the hypotenuse was, we set that hypotenuse equal to x square root of 2 in order to solve and find those leg values. Okay. So here again, now I just start going ahead and solving for x. Divide by square root of 2, divide by the square root of 2. Now I'm left with x equals 9 square root of 3 divided by the square root of 2. Okay. Unfortunately, now I have this unrationalized denominator. Before you jump immediately to the quotient rule, we need to rationalize this denominator instead first. So let's go ahead and do that. We're going to multiply both the top and the bottom by the square root of 2. And that's going to give me, I already know what's going to happen on my denominator. It's going to leave me with just 2. Notice how up top here I have, I'm going to just write it off to the side here, 9 square root of 3 times the square root of 2. Okay? Again, I am just multiplying radicals here. So this is where I'm going to come in and I'm going to use that product rule that we talked about on the first page of those notes. Now, I have a coefficient of 9 in front of this one. I don't have a coefficient in front of this one. Well, I do. It's just 1. So we don't have to write it there. So I'm still going to be left with 9. And then I'm going to multiply my two radicands here together. So the square root of 3 times the square root of 2 equals the square root of 6. I don't know the square root of 6. I can't find the square root of 6, so I just leave it square root of 6. And then I look and see, can I simplify 9 over 2? I can't. So that leaves me with x equal to 9 square root of 6 over 2. And because this is a 45, 45, 90 triangle, that is also what y is equal to. 9 square root of 6 over 2. Okay. So, this is what all of these are kind of in reference to, I guess. Or not in reference to, but all of these, you're using those new rules that we learned about 30, 60, 90, and then 45, 45, 90, those special right triangles. I do want to briefly, before I end this, want to just look at 22, because there is kind of something interesting here. So, looking at these two triangles, I need to find, let's see, I have two kind of triangles. I have this triangle here, which is a 30, 60, 90, and then I also have this one here, which is a 30, 60, 90. I also have this larger right triangle here, but I don't really... No, I will need that. Sorry. I'm like sitting here looking at it. No, I will need that. Okay. So, I lost my train of thought. Forgot what I was saying. Anyway, okay. the reason I wanted to look at this one was because of this short side of this. I want to look at this little 30, 60, 90 special triangle, okay? It's basically the only piece of information I'm given as far as sidewise. I'm only given that this little piece here is 7 square root of 3. So this is, again, here's my 30-degree angle. So there's my short side is 7 square root of 3. I can then find my long side by multiplying that by 2. So x equals 2 times 7 square root of 3, which just gives me 14 square root of 3. So that one was easy because this x here is my hypotenuse of that triangle. So x equals 14 square root of 3. That one wasn't too bad. So the reason I wanted to look at this one here is you can use this side x and this larger triangle here to find y. It's not going to help you anything with z though, because z is just this individual piece here. It doesn't count for this whole hypotenuse of the large triangle. However, I'm going to make it, I want to do it just a little bit easier. I think that'll help us kill 2 birds with 1 stone. So I want to go ahead and find this longer side here, because that's going to help me be able to find y and z. Notice how that's my shorter side of this new triangle, this larger triangle in here. That's going to give me a lot better way to find y and z. Okay, so this is my long side of this little triangle here. So my long side of my triangles, remember, are, I'm going to call this W just because X, Y, and Z have been taken. So W, is, in this case, is equal to 7 square, oh good grief, 7 square root of 3 times the square root of 3. Okay, and I just wanted to show you this here because remember what happens when we take the square root of something times itself. That radical just goes away. That just leaves us with 7 times 3, which equals then 21. So that means this little side here is equal to 21. Now that we have the short side of this bigger triangle, I can use those values to find z and y and go from there. So I'll let you finish those out. I just wanted to show you this one here because I wanted you to be able to see that you have to, when you take this times the square root of 3, those radicals cancel out. You know, square root of 3 times the square root of 3 is equal to the square root of 9, which is just equal to 3 because of our cool product rule. Okay. So that is all that I was going to go through for us today. Watch those rules, those product rule, quotient rule, sorry. Watch those rules, those product rule, quotient rule, when dealing with radicals. Don't forget to rationalize the denominator. I can't stress to you enough how important it is to rationalize the denominator, and maybe I'll even write that up here for you guys. Rationalize denominator. Okay, and make sure that you simplify. I don't want to see any numbers where you don't simplify, okay? I don't want to see a 8 square root of 3 over 4 when we know that 8 divided by 4 is 2. I don't want to see that. So make sure that you're simplifying. Okay, that is all I have. Take the extra time to go ahead and do the rest of these practice, and then pick ones that you want to go over in class tomorrow if you would like. Send me a message if you have questions. I will do the best I can. and we will look at these things tomorrow.